Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Picture a busy HVAC dispatch. A technician dictates, "Replace the 6-inch duct," into his phone. The speech-to-text system, trained on conversational English, hears, "Replace the 6-inch duct." A parts order goes out for a toy, not a duct. The job is delayed 2 days, and the customer leaves a 1-star review. This happens because generic speech models have never heard your industry's vocabulary. In this video, we're going to fix that. By the end, you'll know how to build a speech system that never confuses a critical part with a rubber duck, and how to apply that same discipline to any jargon-heavy domain. We're not just talking about theory. By the end of this video, you'll have 3 concrete deliverables. 1, a custom speech-to-text model that understands your domain's jargon, so you never get duck instead of duct. 2, a real-time translation pipeline that can dramatically cut the load on your multilingual support team. And 3, a text-to-speech voice that uses speech synthesis markup language, or SSML, a markup language that controls pronunciation, pauses, and tone to sound genuinely helpful, not canned. These are production patterns, not quick-start demos. Let's jump in. A generic speech model may perform well on everyday conversation, but the moment it encounters domain-specific terms like SEER rating or duct, the error rate spikes. That's not a minor hiccup. It derails production workflows. The common mistake: assuming a model trained on general conversation will handle your industry's jargon. The fix is a custom model trained on your own audio and text, so it learns exactly the words and phrases you use. That's the difference between a useful tool and a liability. Azure Speech is not a single API. It's a set of AI services working together. Speech-to-text converts spoken audio into text. When the default model doesn't fit your domain, you can train a custom model for better accuracy with your specific vocabulary. Text-to-speech generates natural-sounding speech from text, using custom neural voices. Speech translation combines recognition, machine translation, and optional synthesis to deliver real-time multilingual output. Speaker recognition identifies who is speaking by their voice. Understanding the component you're using is the first step to building efficiently. For pricing, consult the latest Azure AI speech documentation. Once you've trained a custom model, Speech Studio gives you an endpoint ID. You need to set that on the speech config object before creating the recognizer. If you forget, the service could use a different model, and that's when duct becomes duck. Always double-check the SDK docs for the exact property name in the version you're using. You can quickly check your speech resource provisioning state with the Azure CLI. Run the show command, query the provisioning state field, and when it returns succeeded, the resource is likely ready to handle audio. If it doesn't, wait a few seconds and try again. This is a reliable way to confirm before streaming. Azure Speech expects a specific format: 16 kHz, 16 bits per sample, mono PCM. If you feed it a different format, like 8 kHz stereo from a call center recording, the service has to resample. That process strips away high-frequency details that distinguish consonants like T and CK, turning duct into duck, and breaking the entire workflow. The fix? Stream native audio in the format the service recommends, and you'll avoid resampling artifacts entirely. Before you upload training data, you'll want three things. First, real audio from your actual environment, the same microphone and noise conditions your app will face. Second, accurate human-checked transcriptions so the model learns the correct mappings. And third, a way to teach it your domain vocabulary, like a pronunciation file or text dataset with specialized terms such as HVAC or compressor. That helps avoid the famous duck moments. Inside Speech Studio, you'll create a custom speech project. You'll need to upload two types of data: audio recordings with their exact transcripts to tune the acoustic side, and a text file full of your industry vocabulary for the language model. After uploading, select both datasets and kick off a training job. Speech Studio will show you an estimated training time. While that runs, we'll prepare the client code that actually leverages this custom model. Let's lock in that training step. What two core datasets do you feed into Speech Studio for a custom model? Time for a quick recall. Lock this in before we move on. The recognizer fires events continuously. Recognizing gives you interim text as speech is detected, while recognize delivers the final utterance. In production, always loop through word-level results and log each word's confidence. That's the only way to spot a misrecognized duct before it hits a record. Cancelled fires when the recognizer stops unexpectedly and typically provides error details to help you diagnose. Session stopped indicates the end of a recognition session. If you're running 24/7, use this as a signal to restart recognition and keep the listener alive. Build and run the app. Speak the HVAC phrases that crush the generic model: Freon level low, condenser coil frozen, SEER rating. With the custom endpoint active, Freon no longer becomes Freon. The confidence scores for your domain terms sit comfortably above the generic baseline, noticeably higher. That jump from unreliable recognition to consistent accuracy is the difference between a tool that creates extra work and one that saves technicians time. If a term still wobbles, layer a phrase list on top. A phrase list is a set of keywords you boost in the recognizer for immediate improvement, while you gather more training data. Imagine a financial contact center that deployed speech-to-text to coach agents. Months later, they discover raw transcripts with full credit card numbers sitting in an unsecured cloud bucket. A PCI DSS violation, that's the Payment Card Industry Data Security Standard, could lead to fines and reputation loss. Speech data carries the same weight as a database of passwords. That's where speaker diarization comes in, the process of labeling who spoke when. Multi-speaker diarization helps you isolate sensitive utterances by role, redact PII per speaker, and enforce retention policies that keep you compliant. Treat speech data as a liability until you can prove it's secured. Create a speech config with your key and region. Attach your custom models endpointed if you've trained one. Then swap speech recognizer for conversation transcriber. The transcribed event now carries a speaker ID for each utterance. No voice enrollments needed. That's all it takes to turn a single speaker transcription into a full conversation log. Quick check. After all that work building and testing a custom model, how do you actually make the SDK use it instead of the base model? And if a few tricky terms keep misbehaving, what's the quickest fix that doesn't mean starting training all over again? Pause and think. Then we'll move on. For testing diarization, you might feed in a stereo WAV file using audio config .from WAV file input. But be cautious. The SDK doesn't reliably use channel separation to assign speaker labels. For real-world accuracy, it's better to use multi-speaker audio and let the service differentiate voices. Always check the latest documentation for supported diarization modes. Now let's shift to multilingual support. Picture a company handling hundreds of daily calls in 5 different languages. Paying human interpreters for every interaction adds up fast, and each repetition adds latency. The goal: replace human interpreters with Azure speech translation for standard calls, keeping a person on standby only for complex disputes. The service can stream translations to multiple target languages in parallel. To set that up, you configure the languages you want. Check the current SDK reference for the exact property or method name, often something like add target language. Automating this layer changes the economics, but it depends on one crucial step: getting the grammar right so meaning isn't lost. Create a speech translation config. Set source to Polish and add English as a target. Enable profanity masking using the SDK's built-in masking feature for compliance. Pipe a Twilio audio stream into a translation recognizer, then handle the recognized event to grab the finished translation and send it to the agent's interface. No human interpreter needed. Imagine an insurance adjuster reading a translation of a Polish claim. The machine output swaps claim settlement to settlement of the claim, entirely changing the legal meaning. Machine translation can struggle with languages that use complex grammatical cases, where even a single word ending can flip the message. To avoid this, add a post-processing rule engine that parses the source language's dependency tree, a grammatical structure showing how words relate, like parent-child relationships in a sentence, and rebuilds accurate English agreement. Tools like SpaceI can help you build that layer. This extra pass is often the difference between a tool people trust and one they disable. Human interpreter services can rack up eye-watering per-minute fees. Azure Speech Translation, by contrast, can process an hour of audio into 3 languages for as little as $2.80. Check current pricing for the latest numbers. The trade-off? You'll invest engineering time polishing grammar, especially for languages with complex morphology. Think tweaking the dependency tree, which maps out how words relate grammatically. But the cost savings are enormous, and you don't need to hire a single interpreter. When a service like Azure Speech is overwhelmed, retrying instantly can cause a cascade failure. Exponential backoff increases wait times between retries exponentially, giving the service time to recover. Jitter adds randomness so that many clients don't all hammer the service at the same moment. Without jitter, you get a synchronized storm, a thundering herd that can make things worse. In your reconnection loop, you'll need both to keep your app resilient. Here's a real production pattern for handling disconnects with the Azure Speech SDK. You wrap the continuous recognition call in a retry loop that applies exponential backoff plus a random kicker, jitter, so all your sessions don't hammer the service at once. It reconnects automatically up to a max retry count, then raises an alert so a human can step in. This is the kind of resilience that separates a demo from something you'd actually run in production. To produce a professional voice, you use speech synthesis markup language, SSML. Inside an SSML document, you can wrap your text with prosody tags to control pitch, speaking rate, and even pitch contour. For example, you might raise pitch slightly and slow the rate for a friendly greeting, Then insert a 500 millisecond break for a natural pause before delivering a serious figure with lower pitch. You then pass that SSML string to the Azure Speech Synthesizer's Speak SSML async method. That's how you go from a default robot voice to a polished, conference-ready delivery. Let's tie it all together. You now know how to build a custom speech-to-text model that understands your domain's jargon. No more duck moments. You can deploy a real-time translation pipeline that handles network drops and grammar nuance, keeping your multilingual support fast and accurate. And you can craft a text-to-speech voice with SSML that sounds genuinely helpful, not canned. These three skills are what separate demoware from a production-grade speech service. Go build something that works. Let's lock in what you've actually built across this session. First, you trained a custom speech-to-text model that crushes domain jargon. No more press 1 for duck. Second, you wired up a real-time translation pipeline that delivers near real-time translations to multiple target languages using a few SDK calls. And third, you crafted a text-to-speech voice with SSML that controls pauses, pronunciation, and speaking style, making automated phone systems sound genuinely helpful. These are production-ready building blocks. Go back to any of those scenes if you need a refresher because you're now equipped to add speech capabilities to real apps. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.